Hi students, welcome to Preliminary Chemistry and the energy topic. This is video number 10 on bond energies. In the last video we had a look at chemical reactions and the energy that's involved, and we looked at how heat energy can be converted into kinetic energy, and we can look at the kinetic energy of the particles, the momentum in collisions, and whether or not that's sufficient to cause a chemical reaction. In this video I want to focus more on bond strength and exactly what is being broken and what is being reformed in order to give us an idea of whether a reaction is exothermic and endothermic and exactly to what extent that energy change occurs. So the first thing is that different elements have different bond strengths, both between their own atoms, so within atoms of the same element, and also when those atoms form bonds with atoms of other elements. And what we can do is we can rank these to describe the strengths of different chemical bonds. We can also use them to determine the net gain or loss of energy when new substances are formed. If you have a look at the table here, you can see things like a very large value for the bond energy between a carbon and oxygen when there is a double bond, a very low energy, if you like, for when oxygen and oxygen are linked in a single bond, and a much larger value when oxygen and oxygen are linked in a double bond. So we can use these values to help us to determine what's actually going on in a chemical reaction. So it's probably easiest if we work through an example to demonstrate this. So in the previous example, we looked at two hydrogen molecules and one oxygen molecule forming two water molecules. And what we've got to do is we've got to break these down so we know exactly what's happened here. So in order to form the water, we need to break the bonds between the hydrogen atoms and between the oxygen atoms. So two hydrogens means we have an HH bond. That's one molecule. So a second molecule would look like this. And we also need to break the bond, the double bond between those two oxygen atoms. Okay, so that's what we have on our reactant side. Two hydrogen-hydrogen bonds and one oxygen-oxygen double bond. Energy is required to break these bonds, and as we'll see in the next video, this energy is called the energy of activation or activation energy. We need sufficient energy put into the system in order to break these bonds. When we create bonds between the hydrogen and the oxygen atoms, it releases energy. So over on the other side, we have a hydrogen and oxygen, and in fact, there will be two of those for each molecule, and because there are two molecules, there will actually be four of these in total, 4 hydrogen-oxygen bonds. As a consequence, we can calculate the net gain or loss of energy in a chemical reaction by subtracting the energy produced when the bonds are formed in product molecules from the energy required to break the bonds in the reactant molecules. So the bonds broken are hydrogen, hydrogen, another hydrogen, hydrogen, and one double bonded oxygen. And the bonds formed are 4 of these HO bonds. It doesn't matter which way we write them down, they're the same bonds. So let's see if we can calculate this. So let's work through an example. First of all, we need to make sure that we remember the process that we have, which is hydrogen plus oxygen combining to form water. So from the table on the previous slide, one of the previous slides, we have an oxygen-oxygen double bond with a bond enthalpy of 498 kilojoules per mole. Hydrogen-hydrogen has a bond energy of 436 kilojoules per mole, and the oxygen-hydrogen has a bond enthalpy of 436. Now these values have just been taken from a table, and if you are asked to do calculations, you'll always be provided with these numbers. You won't have to memorize any of them. So the first step and the important step is always to write a balanced equation. We can't do this process unless we have a balanced equation. And then from that equation, we can identify the different types of bonds that are present. So on the reactant side, there are 2 hydrogen-hydrogen bonds and 1 oxygen-oxygen double bond. If we put the values in, we're going to have 2 lots of 436 plus 1 lot of 498, and that's going to give us a value of 1,370 kilojoules required for this process. For the formation of the water molecules, we actually get energy released, and this energy released is calculated by looking at 4 oxygen-hydrogen bonds, each of which has a bond energy of 463 kilojoules. So when we multiply that value by 4, we get 1,852 kilojoules of energy released. The change in energy, therefore, is the amount of energy that we put in to break the bonds, and then the amount of energy that's released in the formation of the new bonds. And because the amount of energy released is higher, that number is a negative number. And that negative number, which represents an excess energy released, then we have an exothermic reaction. So if the delta H or the delta E value is negative, then we have an exothermic reaction. And so the formation of water from its constituent elements, hydrogen and oxygen, is an exothermic reaction. You'll do a few more examples in class, I'm sure, but just review this if you need some little practice with these numbers. If you look at the table on the first slide, you'll be able to combine a range of different types of reactions together to give you some practice doing these calculations. Thanks for watching.